This is your one-way analysis of variance, also known as one-way ANOVA. This is on Sirkin, Chapter 10. This is, you see your formulas on page 352. We're going to do a quick kind of crash course on how to do the one-way ANOVA with looking at the data, starting on page 339 of your textbook. I'm going to explain their explanation. So go to 339 of your textbook. There's three groups you have. Your samples. The x subscript 1 is your day, your x subscript 2 is your night, and your x subscript 3 is your Saturday. Again, I like to write the squared right to the right of is the regular data for it. It's notice my tables look different than yours. Theirs, I have it combined. So for example, the first one, the data for your first sample, x subscript 1, it goes 5, 5, 5, 5, 4, 4, 4, 4, 3, 2. You add that column together. Summation x subscript 1 equals 41. Then I work to the right. Okay, I square those. So I'll just square the first one. 5 times 5 is 25. And you work your way down and then you add those together. When you add that whole column together, you come up with summation x subscript 1 squared equals 177. Then you work to the right. Your next sample is your night. X subscript 2, your second sample, the data is 5, 4, 4, 3, 3, 2, 2, 2, 1, 0. You add that together. Your summation, x subscript 2 equals 26. Work to the right, I square that. So example, the first one's 5, 5 times 5 is 25, second one's 4, 4 times 4 is 16. So after I do all of those, I add them together, and that is my x, my summation, x, second sample squared, subscript 2 squared, and then my third set of data, which is Saturday, x subscript 3, which starts with 5, 5. I add all those together, I come up with summation x subscript 3, 38. And again, this is your textbook. X, and then I work to x, the third set of data, and I square it, x subscript 3 squared. First one's 5 times 5 is 25, second one 5 times 5 is 25. I work my way the whole way down. When I get done, I add them together, and that's summation x subscript 3 squared, which a total comes to 154. The next thing I do is your n total. For this one, each sample size is 10. So the n1, the n2, and the n3, all that means is your first, second, and third sample in this case, because we only have 3 samples. So 10 plus 10 plus 10, so that equals 30, so your n total equals 30. The next thing we do is your summation x total. That's what I like to do next, which is summation. That's your regular x columns before you square them. That's all that is. So before we square them for the first set of data, that's 41. Second set of data is 26, so it's 41 plus 26 plus 38 equals summation x total equals 105. The next thing we do then is we add together our summation x squared total. So your first set of data, your summation, your x squared is 177, plus your second set of data is 88, plus 154 for your third set of data. We add all those together, 177 plus 88 plus 154 gives us 419. Now we're ready to go on to the formulas you see here on the left. We're going to work in order from top to bottom, because that's the way to make it work, the G or ANOVA. So your SST, or your SS total, is your sum of the x squared total, which over here is 419, we just calculated that, remember, minus 105, which is your summation x total, which is right, we did that, 105, that's going to become squared over your n total, which is 30. Okay, so what we do first is we show our professor all the work. Okay, so it's 419 minus, first we go 105 times 105 is 11.025 divided by 30, and then equals 419 minus, because we're going to then divide 11.025 divided by 30, minus, which would equal 367.50, so it's 419 minus 367.50 is 51.50. That is our sum of squares total. Now we're going to our sum of squares between. which is the sum of the x1 squared over the n1. So we're going to work our way through. The 41, where they got that one is from here. The end of the column of the summation x1 is 41, and then that will be squared later, but that's going to be over 10. And our next number we plug in is our summation x subscript 2, which is our sum of that one, which is 26. 26 goes there, and that's over 10 because our total number of data for the second set is 10. And then our next number, our summation x subscript 3, which is 38, that goes over 10, and that you'll be squared. You subtract that from your total number, your summation x total, which again is 105, and that's going to be squared later, divided by 30. So the first thing we do is we square that number up top. 41 times 41 is 1,681 over 10, plus 26 times 26 is 676 over 10. Then 38 times 38 equals 144 over 10. And then what it is, 105 times 105 is 11025 over 30. We show all of our work. We show the steps. So the next row here, SS between equals, you go 1681 divided by 10 equals 168.10 plus 676 divided by 10 is 67.60. And of course on this we could even just move our decimal place over 1 point. The 10's place now to 0. If you don't want to key it in your calculator because it's a 10 on the bottom. So, and you're adding that to 14.40 because 144 divided by 10 equals 14.40 minus 11025 divided by 30 equals 367.50. So our SS between equals show all of your work. So you can add these three digits together first, just in case you make a mathematical error. They say where it's at. 380.10 minus 367.50 equals 12.60. So our sum of squares between equals 12.60. We have all of our information now to do the sum of squares within, which is sum of squares within equals sum of squares total minus sum of squares between. We have those numbers. So let's put them in. Sum of squares within is sum of squares total, which is 51.50, the number we calculated up here, minus 12.660, the one we just did, equals 38.90. So our sum of squares within equals 38.90. So now we're going to do the mean square between, MSB, equals the sum of squares between over the degrees of freedom between. So our sum of squares between is 12.60. We calculated that right here. And over our degrees of freedom between, our degrees of freedom between is the total number of categories. Think of there's, like I was saying before, there's 3 sets of data. So it's 3 minus 1. So then we show our steps, 12.60 over 2, because take 1 from 3, you get 2. Divide 12.60 by 2, and you get 6.30. We're almost there, ladies and gentlemen. The next one is mean squares within. So I'll just put a little line so you can see the difference here. Mean squares within equals sum of squares W over degrees of freedom within, DFW. Now, what that is your sum of squares W, sum of squares within, which is 38.90, and that's going to be over, okay, to figure out the degrees of freedom within, that's the formula you saw right over here, degrees of freedom within. So we're going to go through that. That's the n total, which we figured out, which is 30, minus 1. And then you're going to subtract that by the total number of categories, which is 3, minus 1. Show your steps again, ladies and gentlemen. That equals 38.90 over 29 minus 2. You take 2 from 29, you get 27, so that's 38.90 over 27 equals 1.44. Hey, we can figure out our F now. Isn't that cool? F equals mean squared between over mean squared within. So, hey, we got these. The mean squared between is 6.30. That goes on top. And we just calculate our mean squared within. 1.44. That goes in the denominator down. The number down there. So it's 6.30 divided by 1.44 equals 4.375. Yes, we're almost there. You consult your table. I think it was like 10.2 or something like that. It says right in the textbook there. So you look at where it is, your degrees of freedom. You look at 2 and 27. Okay, you look at your degrees of freedom, which is between and within, which is 2 and 27. You look at your table to find out where your F crit is for that, your critical value at the 95%, which is the P of 0.05. So your F crit is 3.35, which that is smaller than RF, which is 4.375, which means ours is a higher level of significance. It's a bigger number. So it is significant at the 0.05 level. Now in the textbooks, the next one it looks at is your F crit for your 0.01 level of significance, which the F would be a 5.49. Oh, that's bigger than RF. RF is a 4.375. It's not significant at that level because ours is smaller than theirs. Okay? And our level of significance isn't as high as theirs then. So the way you'd write it is your P is less than 0.05, thus you reject the null hypothesis. This is like a quick cram course version of how to do the hand calculations for a one-way ANOVA using the data in your textbook. Bye.